Assalamu alaikum. Welcome you all to discuss. Today we are going to discuss regarding the A-level chemistry, and we are going to start from atomic structures, and then we know that um, the A-level chemistry is much more deeper than O-level chemistry, so it needs proper care for achieving the target. For doing good in the A-level chemistry, you should have to study more and more. There is no alternative of doing good without working hard. Too much hard work is required for doing best or achieving the best score um, at A level. And in case of chemistry, you should pay proper attention and as per instruction that has been given to you time to time. Without this, it is not possible. It will not be possible for you all to do well. The questions that has been discussed for chemistry and the solve papers from the previous year's questions have been added to each and every student's page. So all students are being advised to take care and to follow the instructions of the each video and the page instruction that has been given to your page. So have your time and study more and more. And if you face any problem, you can also comment to our video sections, and also uh, can solve by calling me, or you can WhatsApp me so that I can provide you the details guideline. So in case of your any doubt or any problem should be clear uh, from your point of view, so that you can join with me with your proper concentrations. And one more instruction is more important. One more instruction is more important to focus on you. That is, you have to be regular in your course materials. The course materials that have been provided, that will be provided to you, you should have to be regular. Without being regular, maintaining regularity, it is not possible for you to have a complete concept and to do all as per instruction, as per expected level. So for achieving the target in the expected level, there is no alternative. There is no alternative to without being regular. So you have to be regular to your course if you want to, achieve your target. So if you have a dream for chemistry, if you have a fascination for chemistry, or if you have a have the dream for going to medical or engineering level of courses in later, so there is no alternative of chemistry. So you have to learn each and every topics, and have to practice again and again. No alternative for practice. Only practice can fulfill your dream. No teacher can do nothing for you. I repeat, no teachers can do nothing for you. You can do everything for you. Keep in mind, no teachers can do anything for you. Only you can do for yourself, nothing else. No one can do anything for you. So be careful for using your time. Let's start in our today's class. In our today's class, we should learn from the atomic structure. And I am considering that you have the suspected level of uh, mm, sorry, you have the suspected level, uh, if you have if you want to uh, do well in the A level chemistry, then the basic from the O level chemistry is also required. I'm suspecting that there are certain level of basics have been developed from the A level. In that case, we should learn regarding the basic, and we should try to go with the basic. If you face any problem without this, should inform me so that I can go for solve class. Then Uh, as per the Hund's rules of maximum multiplicity, we should, though we do not explain in details, but we will explain in later in our next video. But today, with the basic of Hund's rules of maximum multiplicity, we should learn, we should solve a few questions, which are very important for our final exam. So be careful in understanding the solution that we are going to do. It was from the atomic structures, and that is the question is about the electronic configuration of group 2. So in case of group 2, sometimes in the final exam, you may be provided the periodic tables, but in some cases it would be better if you can memorize the element name, especially which group. I'm telling you which group element to be memorized if possible. If you do well, actually, if you do well or have the proper concept on for chemistry, then you should remember some one things. Let me show you periodic table. Okay, periodic table image. I can show you. You can take note also. This one. Let's have a look. This is our periodic table, and can I enlarge it? Enlarge it. Okay, is it? No. Copy image. Okay, copy image, and I paste here. Okay, no. Okay, let's see. This one. Okay, this one. Let's see. Okay, I hope you can see now. You can now see this one. Just try to just have a note. You what you remember? Remember the atomic number and the mass number. Atomic number and mass number to be memorized. Why we should memorize? Because it will help us to understand and to answer faster. This is the region for which we will remember. Which one? This one, group 1. 1A, that means hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. This one. And 2A, from 2A, barium, magnesium, calcium, and strontium, up to this level. Barium to strontium. And row, uh, column 3 দরকার নাই, column 3 ইন্টারনেট, column 4 দরকার নাই, 5 6 7. 7 magnesium should be memorized. 8 from column 8, ferric or ferrous should be memorized. Cobalt should be memorized. Nickel should be memorized. Copper should be memorized. Zinc should be memorized. Silver should be memorized. Mm, and mercury should be memorized. The element, the name of the element that I am telling, you should take note, and you should memorize the atomic number and the mass number if possible. Atomic number should be memorized. Okay. Boron, aluminium, gallium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, iodine. This one, up to this one, halogen group, fluorine, chlorine, bromine, iodine, and the helium, that is inert gas, helium, neon, argon, krypton, xenon, radon, up to this level. So what we need to, why we will remember the atomic number? Because it will help us to formulate the electronic configuration easily. And why do we need to know the electronic configuration? Because it will help us to answer the questions for the final exam. We will solve these types of questions. You will see what types of questions are being set or been asked to answer. So these are the elements that we will remember, but you should have proper concentration of this element that I have already told. And if you do not, if you cannot memorize the mass number, but should memorize the atomic number, it will also help you. And mass number, it will help you to find out the atomic mass of an element. You should be asked to find out the atomic, to calculate the atomic mass. So it will help you to do the answer easily and faster, other than it will save your time at the exam, because you will find out the atomic number or mass number, then you will calculate, it will take time. So in that case, you can go faster and can answer faster. So if you have the dream for chemistry to do all in the final exam, or having the greater score or the best score in the final exam, you should memorize this one. This is very important, very important, and it will be helpful for all your exams in futures, for medical or for engineering, or for any scholarship exam outside. And if you also want to go outside, it will also help you. So this is very important to keep in mind. And how you will remember this atomic number? You can remember this the atomic number by watching or by reading every day. Once upon a time, you will see that you can easily tell. Just you will read and you will try to say without from memory. Just recall from memory every day one time. Every day one time. In the morning one time and the evening one time. Then you continue 10 to 15 days. After 10 to 15 days, you will see that you can tell the atomic number. Firstly, you can go for 1A group, and then 2A, and then 3B, and then 4B, and then 5B, and then 7B, and this way you can practice. And then halogen group. Halogen, what is the halogen group? Halogen group: helium, neon, krypton, argon, xenon, radon. These are the halogen group. And the fluorine, chlorine, bromine, these are the inert gas. And halogen group: fluorine, chlorine, bromine, iodine. These are the halogen group. And then there are common element, non-metallic: boron, carbon, nitrogen, oxygen, phosphorus. Boron 5, carbon 6, nitrogen 7, oxygen 8, and fluorine 9. So fluorine, we should memorize fluorine, chlorine, bromine, iodine together. 9, 17, 15, 35, and 53, in this way. So these are most important things from the periodic table. We learn from more things from the periodic tables, so that will help us to answer the questions in the final exam. There are so many incidents here in the periodic table to explain the chemical behavior of the element. But firstly, as per today, we are going to learn only the atomic number. What will be the atomic number for an element? The atomic number should be equal to the electron number. Now let's go to our board, and we'll try to understand the whole things together, and we'll try to understand the whole things together. uh, mm, Now this one. Okay, this one. So now today our discussion is regarding the electronic configuration. Okay, so we will learn the electronic configuration and the relevant questions that are very consequence and have been raised have been stated in the previous year's exams. So firstly, we will learn the basic, and then we will answer the questions. Then what is atomic configuration? The electronic configuration for atom. Electronic configuration means electronic configuration. What does it means? Electronic configuration means the disposition of electrons. What does means the disposition? Disposition is means that the scattered the position of electron in the different orbital, not orbit. We are not talking about orbit. And have the clear pictures in your mind regarding the orbit and orbital. Orbitals, orbit and orbitals. Let me tell you one thing. These are the orbits. Let me tell you one thing. These are the orbits. This is this one first orbit, this is one second orbit, this is one third orbit. The concept of orbit comes from the Rutherford atomic model or solar system atomic model, but the orbital comes from the concept of or from the theory of Niels Bohr. So we are talking about orbital. In case of electronic configuration, as this is not related to your A-level chemistry, so we are focusing on the orbitals concept. So what is the orbitals? Orbitals are the three-dimensional space of around the nucleus, and that's it can be divided right this way, s, p, d, f. These are the orbital. S orbital contains two electron, two electron in this way, and p orbital contains six electron. This one, this one, this one, this one, this one, this one. D orbital has five room. This one, this one, this one, 1, 2, 3, 4, 5, and F orbital have the seven room. This one, this one, this one, this one, and this one. Seven room. So our discussion is related to up to d orbital, not f orbital. Slightly, mainly s orbital and p orbital. So we know that this one first orbit has the one s orbital, and two orbit second orbit has the one 2s 2p, right? 3s 3p and 3d, 4s 4s 3d, this way. But our discussion is related to this one up to this level. Not we are going to the complex level, as your syllabus will not cover. So focusing on the syllabus, we will go for this one. So these are the internal mechanism of dividing or showing the electronic configuration. As you know that s orbital contains two electron, p orbital contains 6 electrons, d orbital contains 10 electron, f orbital contains 14 electron, and more. In this way we'll go on, but our discussion up to this level. So when you will think for carbon 6, carbon atomic number 6, atomic number 6, okay. Atomic number 6 means what? Each and every element neutrally chargeless. I mean, sodium atom is 0, means that 0 or sodium. This, what is the difference between this? Can you tell me what is the difference between this and this one? What is the difference?
So one has ion, one is an ion and one is a like atom.
Okay. What is the atomic number here? Can you tell me?
Okay.
What is the atomic number of sodium 0? What is the atomic number
Okay.
of sodium? And what is the atomic number of sodium ion?
So the extra one.
No, extra one, no.
No, sir, the total 11, like the number on the periodic table.
Right, 11. 11. This is the atomic number. Atomic
Yes, sir.
numbers means what? Atomic numbers for any element in the neutral condition. For any element in the neutral condition, atomic number equal to proton number. Proton number equal to electron number. Save this information to your mind for the lifetime. Atomic number equal to proton number equal to electron number for any chemical species at the neutral point. So when you are considering for sodium, it means that sodium atomic number is 11 in the periodic table, so it has 11 positive charge. 11 negative charge. So each negative charge will cancel each positive charge, and ultimately the element will be chargeless in the neutral condition. But in case of one positive charge, it means that what is the positive charge number? It means that the atomic number is 11. Atomic number is 11, but that means that atomic number 11, positive charge is 10. তার মানে proton number proton number equal to 10. It means that it means that electron number, how many electron are there
Yeah.
in case of sodium ion?
Sir, one will be extra. No, sir, one will be less because of
Right. That is
giving
number
one
of
away.
electron will be 10. Right.
Yes, sir.
Then what is the mass number? Mass number means what? Mass number.
Mass number of which one?
In
Sodium.
case of sodium ion, mass number equal to proton number P plus N. তাই তো?
Mm. Yes, sir.
P plus N. Proton number in and হচ্ছে neutron number. Right? What does
Yes,
the
sir.
stay? Proton stays at the nucleus. Neutron stays as the nucleus. Right? Is it clear?
Yes, sir.
So from this
Yes, sir.
from the concept of atomic number, I hope you can do this as it was the O level concept. Um, you can easily find out the mass number. You can easily find out the proton number. You can easily find out the neutron number. You can easily find out the electron number for any element,
Yes.
for any ion. Right? These types of question will be asked, but in a technical way. Now let's see what are the technical ways that can be asked to you. One question we are considering one question. Uh, Before going to learn that, just for understanding the questions, we will learn one information. Okay. As we have seen in the earlier in the periodic table a few times earlier. Can we open the one again? This one, this one. Okay. This is the periodic table. Okay, this one. So in this case, when we are going down from top to bottom, the atomic radius is increasing, right? Can you understand this concept? Do
Yes,
you?
sir.
Atomic radius is increasing.
Yes, sir.
What does it means by atomic radius is increasing? What indication are providing to us? Atomic radius is increasing. It means what radius is indicating us. It means we will learn. Uh, as you know, the from top to bottom in a group, top to bottom in a group in a periodic table, if we go in this way, okay, we most probably we have here this one. If you go in this way, then you will see this one. If you go down in this way, then the radius, atomic radius will increase, right?
Yes.
You can also see here atomic number, symbol, element name. No, here is not that. Okay, I will send you in later in our next class. We will come up with that slide, animated slide, in which you will see how the atomic radius is increasing. But just for now, to solve the question, you should keep in mind that atomic radius is from the top to bottom is increasing. Why? And if the atomic radius is increasing, then what will happen? Now we will learn the coincidence. Coincidence for the cause. Cause, what is the cause? Cause is that atomic radius is increasing from top to bottom. This is the cause. Effect, what will be the effect? So atomic radius is increasing in this way, in this direction. It means that the nucleus and the outermost cell orbit is, the distance between the nucleus and the outermost cell is increasing. So from top to bottom in a group, if we go down, then this distance will increase from the nucleus to outermost cell. When the distance will increase, the nuclear charge, nuclear charge on the outermost cell, or the electrostatic force. I hope you have studied the before class, our previous class, so it will be crystal clear to you to understand. Electrostatic force, ESF. ESF on this electron, on the outermost cell electron, will be more less. I mean, the electrostatic force, as the electrostatic force decline, so the removal energy or ionization energy of that element that is staying at the bottom of the element of a group will be very low. Can you understand?
Yes, sir.
If the electrostatic force is declined in a group,
Yes, sir.
why decline in a group? Because the radius is increased from top to bottom. So if the
Yes, sir.
ESF is declined, then the ionization energy will increase. Ionization energy will also decrease. Sorry, will also decrease. So the chances of removal of electron will increase. I mean, electron will be removed from the element easily. So what happened here? When electrostatic force ESF is proportional to ionization energy. Ionization energy. I mean that electrostatic force, when the electrostatic force is more, ionization energy will be required more to remove electron. When the electrostatic force is declined, so ionization energy will be more or less to remove electron. So from a group, from a group, for a group top to bottom, when you will go from top to bottom, the radius will increase. Radius increase means that the ionization electrostatic force will decrease. Electrostatic force decrease means that ionization energy will be decreased. Got my point?
Yes, sir.
This information should be set in your mind strictly, because it will help us to solve so many problems. We have learned only one incident from the periodic table today, and on based on this one information, we will now solve two questions. Okay. Now, question is telling that complete the table below to show the electronic configuration of calcium atoms and strontium ions. Calcium atom. So what is telling that electronic configuration? Question is telling us to write down the electronic configuration of electric calcium, electronic configuration of calcium and strontium 2 plus. So uh, firstly we go for try to understand this one. Calcium. Now, if we go to the our periodic table, we will just see here what is the calcium means that calcium. What is calcium? Calcium. This is the 20 atomic number 20, right?
Yes, sir.
So we have to find out the electronic configuration. Okay. So 20, for 20 we will find out the electronic configuration. So we can write here. This is 20. This is 20. 20 atomic number. So we'll now write the electronic configuration. 1s2, 2s2, 2p6, right? 10, then 3s2, 10, 12, 3s, 3p, 6, 18, 4s2, 20, right? 6, 4,
Yes, sir.
10, 10, and 10, 20. This is the electronic configuration of calcium. Question is, you have to write the electronic configuration. This is the electronic configuration of calcium. Can you understand this? Did you uh, did
Yes,
you
sir.
did you do this before?
Yes, sir.
Okay. So your task is you should write down the electronic configuration and send me by tomorrow 4 p.m.
The electronic configuration of which one?
I'm telling you. Now, in case of calcium, this one, if the 2 plus, then you have to write it, and then this one will be abolished. That means we will write up to this one. 1s2, 2s2, 2p6, 3s2, and 3p6, and this up to this level. Okay, because 2 electron is less than this one, right? So in this way, you
Yes,
should
sir.
write the electronic configuration. Take note in your exercise book. Which one? Sodium. You will write the electronic configuration: sodium, sodium ion, magnesium, magnesium ion plus 2 plus, huh? and
Yes, sir.
uh, and carbon and nitrogen, sulfur, phosphorus. You should write by yourself, like this one, and send to me by tomorrow evening. Tomorrow evening. Take note at your exercise book. Now, this is the electronic configuration related questions. Now, our next question, the is electrons group 2 decrease with increasing proton number. The first ionization energies of the element of group 2 decrease with increasing the proton number. Okay, next question. We are going to the next question. Uh, just for information, should keep in mind carbon. Carbon atomic number 6. This is the electronic configuration of carbon: 2s, 2p, 1s2, 2s2, and 2p, 6, 4, right?
Yes, sir.
4, 5, 6, 2. This is 2. This is the normal electronic configuration of carbon. But in case of carbon, this one, the electronic configuration will be 1s2, 2s1, 2px1, 2py1, 2pz1. ठीक है? Do you have any confusion
Yes, sir.
regarding this? Do you know the
No,
reason
sir.
why? Do you know the reason why?
So which one?
C plus, excited carbon. Why the electronic configuration is like this?
The extra one.
This one. This is the normal electronic configuration of carbon. But why we have write this? In which case?
Sir, because yeah, it is in ion form.
No, I inform no. When this is the effect of Hund's rules of maximum multiplicity, and as a result of this, carbon electronic configuration shows this when form any bond to any other element. This is the normal, and from the for going to the bonding stage, this the configuration is changed.
Yes, sir.
Okay.
Yes, sir.
Now you can do that, practice again and again, the electronic configuration for the element that I have told you, and we are now going to, okay, functional group on the gaps in the table. Carbon 13, sulfur 34, iron 54. Now another thing we should try to learn. Uh, uh, did you study the note of isotope that I given in earlier classes? Did you read that? Isotope, regarding isotope. It was at your page. Did you get that? Can you hear me?
Oh, yes, sir. Yes, sir.
Did you study the isotope?
Sir, I revised, but yeah, didn't do it that well. Some of the parts are left.
I did not get you. Can you repeat?
Some of the parts are left. I yeah revised half.
Oh, okay, okay. Then we are not going to discuss right that from the isotope. You should first cover that one, and then we'll go for the isotope discussion. Isotope related, there are a few questions regarding the isotope. Okay, so in that way we learn that, and just one diagram shows the behavior of the separated beams of electrons and protons in an electric field. Charge on plate, electrons and two. Okay. So, as we are not discussing regarding isotope, we can go for uh, this one is okay. Now, summarize the atomic structure chapter. In case of atomic structure, what are the important topics that to be studied from the atomic structure? Let me explain you. One thing, one thing, what is atom and what is the difference between the atomic particle and wave? This is most important. You have to have clear concept regarding this. And then nextly, the element that I have told you to memorize the atomic number and their electronic configuration, and to find out the mass of a compound, mass of an element or compound. And nextly, the use of ionization energy, the use of atomic radius, and the electrostatic force, nuclear charge, and nuclear charge, and Hund's rules of maximum multiplicity, and electronic configuration that we have already discussed. Do you have any problem regarding this chapter that your teachers you have learned from other sources? Do you have any problem regarding atomic structures?
No, sir.
Okay, can you find out the atomic mass of an any element, like see water? Can you find out the molecular weight? Do you know the what is molecular weight?
Molecular weight.
Right? Can you find out the molecular weight? Can you calculate the molecular weight of water, sulfuric acid?
Yeah, mass or like weight. I don't know.
Molecular mass, you can also say molecular mass. Can you find out?
So, so I need to see, but I think I did it.
This one, I can show you that one things. It will be required because questions will be asked from these sections. This one. Let's an example of water. Okay, we will find out the molecular mass. This one. So what is this? 1 into 2 plus oxygen 16.
Yes, sir.
So 2 total 18. This is the molecular
Yes,
mass
sir.
of water. In this way, what we have to learn? Sulfuric acid. You will try yourself one. The which are you facing problem or not? Carbon dioxide, nitrogen peroxide, carboxylic acid, acetic acid. These are important chemicals that I'm telling you.
Yes, sir.
Hydroxyl, hydrochloric acid, HNO3, nitric acid, phosphoric acid, H3PO4, phosphorus acid, nitrous acid, and nitrous oxide, nitric oxide. These are the molecules. You will try to find out the molecular weight. Are you facing any problem or not? Got my point?
Yes, sir. Yes, sir.
Now, there are a few math from this chapter. We will go for math tomorrow night, maybe, and Hund's rules of maximum multiplicity. This with this lecture, the atomic structure will be covered, and no more things will be required from these chapters, and that I have already discussed to find out what types of questions will maybe asked to you. And now you will tell me, you will have a note what types of problem you are facing from the atomic structure. So for doing so, you should go a complete revision of atomic structure that have been asked or that have been instructed you by the coaching or any other teachers that you are getting information from the teachers. So review the all note full chapters, and find out the problem, and note down, and ask me tomorrow night. Got my point?
Yes, sir.
So that we can sum up the whole chapter as a complete chapter as a whole. And after completing the chapter, we'll go for have 2 or 3 days for revision, and then we'll go for a complete exam like A level exam. Got my point?
Yes, sir.
So your job is to find out the problem from this chapter. So you will get problem when you will go for revision, and the topics and the information that I have told you to memorize, you should do that. After doing that, you will the problem will be find it out, we will solve, and I will explain Hund's rules of maximum multiplicity, and the few math that are important from this chapter. I will give you the complete note of math so that you can understand and get the complete idea. And you will practice also the
Yes,
math that will be required. And at the end of the class tomorrow, we will solve your problem regarding this chapter. And with the closing of the tomorrow lectures, our this chapter will be closed, and we will go for chemical bonding. Got my point?
yes, sir.
Okay. So that's all from today. And the note the point that I have already discussed, I will send you the complete note within 1 hour. Okay, at your page.
Yes, sir.
Okay, bye.